Dear students, welcome to Chemistry Classroom. In today's lecture, we will discuss an important topic in stoichiometry called limiting reactant in a reaction. We will solve a numerical problem based on the topic so that you would get a good comprehension of the concept. First, I'm going to explain what is limiting reactant in simple terms. Let's imagine we have two sets of balls, red and pink. Suppose we are going to make a pair of a red and a pink ball, then based on the number of the balls, imagine how many pairs we could make. Here you can see we have only 4 pink balls while the number of red balls are 6. This means we can only make 4 pairs because the number of pink balls are just 4. Even if you increase the number of red balls, it won't affect the number of pairs that are going to form by pairing two sets of balls. What does this actually shows? This shows that the pink balls are actually controlling the process of coupling of these balls. This analogy can be applied to a chemical reaction. When a reaction starts, normally one of the species consumes earlier in a reaction. So this particular species actually control the amount of product formed in a reaction. So we can actually define a reactant that produces the least amount of a product in a reaction is called a limiting reactant, or a reactant that consumes first in a reaction and ceasing the chemical reaction. So this is what we called a limiting reactant. Now let's look at a numerical problem so that you could get a good comprehension of this concept. So here is the numerical problem. Calculate the amount of ammonia produced by reacting 100 gram of hydrogen and 130 gram of nitrogen. Identify the limiting reactant and also calculate the excess amount of the reactant left after the reaction. Let's summarize this. Given information, amount of nitrogen given is 130 gram and amount of hydrogen is just 100 gram, and we have to find maximum amount of ammonia produced, and we need to identify the limiting reactant, and finally we have to calculate the excess reactant left after the reaction. First, we need to convert the grams into moles, and this can be done pretty easily. You can see we were given 130 gram of nitrogen and the atomic weight of nitrogen is 14 gram per mole. So simply dividing the weight in gram by the atomic weight, we would get 9.29 moles of nitrogen. So first we will calculate the moles of ammonia produced with respect to nitrogen. According to balanced chemical equation, you can see 1 mole of nitrogen gives us 2 moles of ammonia. So we can write this expression like this: 1 mole of N2 gives 2 moles of NH3. This equal sign simply means give. If 1 mole gives 2 moles of ammonia, then 9.29 moles of nitrogen can be calculated by multiplying 2 with 9.29, and we would get 18.58 moles of ammonia. And if you want to convert it into grams, we can simply do that by multiplying 18.58 with the molar mass of ammonia, which would give us 315.86 gram of ammonia. So this is the amount of ammonia in moles produced with respect to nitrogen, and this is the amount in gram. Now let's look at the amount of ammonia produced with respect to hydrogen. First, we need to convert 100 gram of hydrogen into moles, and that is pretty simple. 100 gram divided by the atomic weight of hydrogen, and this would give us 100 mole of hydrogen. And let's calculate the amount of ammonia produced with respect to hydrogen. So according to balanced chemical equation, you can see 3 moles of hydrogen gives us 2 moles of ammonia. Let's simplify. If 3 moles of hydrogen gives us 2 moles of ammonia, then 1 mole of hydrogen would give us, simply make this 3 a denominator of 2, or simply divide 2 by 3. So 1 mole of hydrogen would give us 2 by 3 moles of ammonia. If 1 mole of hydrogen gives us 2 by 3 moles of ammonia, then we can multiply it with 100 to calculate the amount of ammonia produced by reacting 100 moles of hydrogen, and this would mean we would get 66.66 moles of ammonia. And if you want to calculate it in terms of weight, then simply multiply 66.66 with the molar mass of ammonia, which is 17, and I'm not going to do that. I'm leaving it for you. Please calculate it and write it down in the comment section. So here you can see the amount of ammonia produced by nitrogen is 18.58, which is way less than what is produced by hydrogen. This means it is the nitrogen that would be consumed earlier in a reaction. So this is going to be the limiting reactant. We have identified the limiting reactant which is nitrogen, and we have also calculated the amount of ammonia produced in this reaction, and that is 18.58 moles of ammonia. Since nitrogen was a limiting reactant, this means some of the hydrogen would be left after the reaction. Let's calculate how much is the amount of hydrogen left after the reaction. We can again write this particular equation according to balanced chemical equation. Over here you can see for every 1 mole of nitrogen we requires 3 moles of hydrogen. Then we can write 9.29 moles of nitrogen would require, simply multiply it with 3 and we would get 18.58 moles of hydrogen. So this is the amount of hydrogen that would be consumed in a reaction. So the amount of hydrogen that we had at the start of the reaction was 100 moles. Let's subtract 18.58 from the 100 and we are left with 81.42 moles of hydrogen. This means this is the amount of the hydrogen that would not be used in the reaction and would remain after the reaction is over. Now convert 81.42 moles into grams and give your answer in the comment section. So that was it for today's tutorial. I hope you have found this tutorial useful. Please give this video a thumbs up, subscribe to my channel, and thanks for watching.